In this problem, we're asked to implement the insert and delete functions for a doubly linked list. It's a big problem, so we'll look at insertion first. As mentioned in the description, doubly linked list nodes contain not only a next pointer, but also a pointer to the previous node in the list. This allows us to traverse forwards and backwards in the list. Before we begin, let's go over the cases we need to address. Since doubly linked lists aren't too different from singly linked lists, we'll simply address the same cases as when we worked with singly linked lists, adding and deleting from the beginning of a list, the middle of a list, the end of a list, an illegal index such as a negative index or an index larger than the size of the list, and an empty list. As we learned earlier, for singly linked lists, the beginning of the list is a special case because we have to change the head of the list. That's probably still the case. But for doubly linked lists, the end of the list is also potentially a special case. When we insert into a doubly linked list, we need to update the pointers of the nodes both before and after the node being inserted. But if we're inserting at the end, there is no after to update. As we go through these cases one by one, pause the video and sketch a diagram of how we're modifying the list, just like the insertion examples we just did. Let's start with inserting at the beginning of a list. We encounter this case when insert is given an index value of 0. In this case, since new node will be the new front of the list, we can immediately set its previous pointer to null, while its next pointer should point to the current front of the list, which we could get by dereferencing list. Next, we need to change the previous pointer of the original front of the list, since new node now precedes it. But we need to be very careful when dereferencing pointers. This line is problematic since there's a case where star list could be null, the case where list is empty. To get around this, we'll guard the statement with an if, so that it executes only if the list isn't empty. In other words, if star list is not null. Finally, since we're setting new node as the front of the list, we need to update star list so that it points to new node, and then return 0 to reflect success. Since we've finished one case, let's run it against our test cases to make sure that it works as we expect. Most of the test cases fail, but the two test cases that deal with insertion into an empty list or at the front of the list work as expected. Looks like we handled one of our cases, insertion into an empty list, at the same time as insertion at the front, and that makes sense since inserting into an empty list requires that we insert at the front. Next, let's insert a node into the middle of a list. When we worked with singly linked lists, we stopped our traversal at the node before our desired index, so let's do so here as well. We'll start by building a traversal. We'll need a pointer to the node we're looking at, as well as a counter to track which index that node is. We'll name these variables cur and curIndex respectively. Next, we'll set our loop to run while cur is a valid node pointer. That is, while cur is not null. That's the core of a traversal, but we need to stop it early. We want it to stop when cur is pointing to the node before our insertion point. That means we need to track which index it's at, and stop when we're at the right place. Now we know that when we exit the traversal, we're either at the right place or the index we received wasn't a good one. So let's take a quick break and deal with the error case. We just need to check if we're at the right index and return an error if we're not. Now that we know we're at the right place, let's handle the insertion. Cur is the node that should precede new node in the list, and whatever comes after cur should be modified to come after new node. First, let's change new node's pointers. Its previous pointer should point to cur, while its next pointer should point to whatever cur's next pointer points to. Now for the nodes preceding and succeeding new node. They should both have their pointers updated to keep the list linked properly. The links we're using look complicated, but just read them from left to right. Cur is the node before our insertion point. Cur next is the node that should be after our new node. So, cur next previous should be the new node. The order of the assignments is important. If we do it in reverse order, we'll change cur next before we try to use it. Okay, that looks like insertion in the middle. Let's run it. Now, illegal indices of all sorts and insertion in the middle works. This case is special, but it's not too hard. What's different about the end of a list? Cur next is null at the end of the list, so we need to guard the statement. At this point, we've covered insertion at the beginning, middle, and end of a list. In the next video, we'll look at removing from the list.